With this video, we're going to discuss section 4.4, theorems about zeros of polynomial functions. Back in section 4.3, we discussed how to do synthetic division and long division, and you had a choice of whether you can use either synthetic division or long division unless the directions specifically said use long division. So this is something you might want to just go back and watch the video just to recap to make sure you understand how to use both. This is also too something we discussed in previous sections on how to find the zeros for this polynomial function. So if you plug in for y1 your equation, and then for y2 you put in 0. And again, if you're using an older model calculator, you won't see this blue and red, but just understand when you put in for y2 0, you have a line that's going through the x-axis for yours. It would just probably it would obviously be the same color, black. But here you can clearly see that we have our two lines, blue and red, and we want to figure out how many zeros are in this equation. Yes, you can use synthetic division, you can use long division, and all the techniques that you've done in this course. This is also a way for us to use the calculator to figure out those zeros, especially if it comes out clean. Clean meaning it comes out like a whole number. So if it comes like a decimal or something, then you're probably going to have to do it by hand. So once you do that, you hit second, trace in the number 5 because you want to find the intersection of where it meets. So take your little blinking cursor and go to where it meets at the first part, then hit enter 3 times. And then you need to repeat the same process. Second, trace number 5, and then now take the little cursor, go to the second part, and then hit enter 3 times, and then hit second trace again, and then go over here. So just a reminder, don't just go to the point and then hit enter 3 times. You have to hit second, trace, and 5 to reset your calculator to know that you're looking for the intersection for each part. So we have 1, 2, 3 zeros for this one. And how do we know that it's going to be 3 zeros? Because of the exponent. Remember that leading term, the degree of the polynomial will determine how many answers or zeros you will have for this polynomial. So this is a good practice one you can do if you want to try to do all 3 techniques. So you can just make sure you have the practice, do your long division, then do standard division, and then do your calculator for this equation right here. So you can see if you can have all of them down pat. Try your best not to use your notes. Then that way, when it comes test time, you'd be ready for the test without looking back in any notes or anything. Once you actually perform one of those 3, you should get to x plus 3, x plus 1, and x minus 2. And if you find the zeros for this one, again, change the sign. So this is a plus, so the answer should be -3. This should be -1, and this should be +2. So either you use the calculator, long division, or synthetic division, you got to one of these answers down here. Also keep in mind too that if you're doing long division and synthetic division, you won't be able to, I didn't give you what you needed to divide in, but remember what we talked about in section 4.3. Take the last number and find the factors of this last number. So what are the factors of 6? How do we get a -6? We can do -1 times 6, and then -6 times 1, then 3 times -2, and then -3 times 2. Those are all the factors to get 6. So those are the listings of numbers you need to put off to the side, and then go ahead and try your long division or synthetic division to see which actually those numbers will go into these numbers. And another quick way to check is the remainder theorem, is where you take those possible listings that you have off to the side, the 1, the 6, the 3, and the 2, or the negatives, and plug it in for every x. If once you plug it in those numbers and your answer is a 0, then that will be a possibility. That will be the answer for the real numbers. So you don't have to do too much guessing and checking with all those listings. If you just plug them into here, if you get 0, then that's going to be considered to be a 0, that number that you chose. So basically, if we would have chose -3, -1, and 2, all those these three answers will be the only ones that actually give you 0 for the answer. So that's how you use the remaining theorem to kind of quickly check which one you want to use instead of guessing and checking. Now we're going to actually find the polynomial. So this is where I'm actually going to give you the zeros. So I'm going to give you -3. I'm going to give you -1. I'm going to give you 2. And you need to put it back into x plus 3. So take this one here, change the sign, make it x plus 3. Change this one, make it x plus 1. And then change this one, make it x minus 1. Then we're going to distribute. So we do these first. You only can do 2 at a time. Don't try to do all 3. Do these 2 first, multiply them together, get your answer, and then multiply this one in and get your answer. And you should come up with this long polynomial right here. So this is the next stage of this lesson is now I'm giving you the zeros and we're kind of going to work backwards now to get to our polynomial, what it looks like. So this here, find the polynomial function of a degree of 3. So degree of 3 meaning again, we have 3 zeros, 3 answers. So we have to change this one. This is a positive one. So more than likely, this is going to be an x minus 1. This is a positive 3i, so it's going to be x minus 3i. And this one is a negative, so this is going to be x plus 3i. So x minus 1, x minus 3i, x plus 3i. So these are my factors. So I took the zeros, my answers for zeros, gave it an x by changing the sign. Now I'm going to put parentheses around each one of these and go ahead and multiply it out. The best thing to do when you're dealing with i's is to go ahead and make sure that you multiply those two together. So I wouldn't suggest you multiplying x minus 1 times x minus 3i together. Multiply the i's together because what happens is the i's will eventually cancel out. And that would make the problem a lot more easier to do. So if you actually multiply these together, distribute x times x, and then negative 3i times this 3i, and then negative 3i times x, and so forth. Just go do your distribute FOIL, or what it's called. You should get the answer to be x squared minus 9i squared, because the x term in the middle will go away. The middle term actually goes away because you have a plus and a minus, and they should subtract out. Also keep in mind, if you ever forget, there's the I feature in your calculator. If you just hit second and then decimal, the I will come up. And if you do I squared or I times I, that's actually equal to a -1. So basically we're doing a -9 times a -1, which makes it a positive. These two negatives here make it a +9. So here, this is where we have x squared plus 9. And now we're ready to do the last part and multiply this in, and we get our polynomial like so. So here's just another example. So if we have a +5, to make it a factor, we make it x minus 5. We have a positive here, we make it a minus, and we have a minus here, we make it a plus. Again, multiply the two i's parts together, these factors together, could make the problem a little easier. Get it to this part, x squared plus 4. Then now we multiply the last part we didn't do yet, and we get this whole polynomial here. So for this one here, find the polynomial function with a degree of 5. So again, if it has a degree of 5, how many answers do we have? We should have 5 answers. So here we have -1 as a 0. So this is going to be our first 0, -1, and it has a multiplicity of 3. So what does multiplicity mean again? Just go back and review my 4.3 section. Multiplicity means is how many answers you should have. So if I told you what is a 0 for x plus 1, that's the -1 here. For the multiplicity of 3, that means we have 3 of these. So we have 3 of these -1s. So that's why we put a 3 as the exponent. We have 4 as a 0, so this one should be x minus 4 with a multiplicity of 1. So there's an understood 1 to be up here. And then we have 0, so this x here, x minus 0, that's going to be our 0. Anytime you just have just an x, the answer for the real solution or real 0 is actually going to be for this one 0. So this one here is -1, +4, 0. And then it has the multiplicity of 1, so we just write the x one time. So once again, you multiply the whole part out. So you take this here. Don't just make this x to the third plus 1. You have to do this 3 times. So write it out if you need to. X plus 1 times x plus 1 times x plus 1. And then you should get this polynomial here. Distribute the x inside. We get x squared. And then it's x times this 4 gives you the negative 4x. Then we have to take this x squared to multiply it here, 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 and here. Then take the negative 4, multiply it to here, 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 and here, collect like terms, and we get this answer here. So here we have a another polynomial function with a degree of 6. Here I'm actually giving you 3 answers. I'm giving you 3 zeros. So if I'm giving you 3 zeros, there should be 3 left because we have we need 6 total. So for this one here, remember what we have to do when it comes to solutions and conjugates and square roots. You always have to do plus or minus. So if I gave you a plus here, then you should be able to a minus for the conjugate. If I give you a minus here, it should be a plus here for the conjugate. And remember, if you take the square root of anything, it's always going to be plus or minus. So we have a minus here, we have a plus here. So we have 1, 2, 3. That's the ones I gave you. And then we have 4, 5, 6. These were the ones considered to be missing. The next topic we're going to talk about is integers, coefficient, and the rational zero theorem. So here, this is what we need to write. You need to write in your notes, P over Q. We need to figure out all the possibilities of factors for P and all the factors for Q. And where does the P and Q come from? The P comes from the last number in the polynomial function or coefficient, and then the Q comes from the first term, looking at just the coefficient. So my question is, how do we get 4? What are all the different ways to get 4? I can do 1 times 4, or negative 1 times a positive 4 to get negative 4. I can do negative 1 times a positive 4 to get 4. Another way to get it, we can do 2 times 2, that gives you a 4. And then for 3, what are the possibilities of getting 3? 1 times 3. So basically, if you just want to make this a little easier for looking at it, is just list the possible numbers. No, you can just kind of disregard the negative here. And whatever it takes to multiply to give you 4, write those listings out. 1 times 4, then 2 times 2. And then always put a plus or minus in front. So what are the possible factors to get 3? Where the only way you can get 3 is 1 times 3, and then put a plus or minus in front. So basically, you're just listing out the factors to multiply to give you that number, and then you just put a plus or minus for each number that you come up with. Remember again, the P goes on top in the numerator, and it's the last one in the equation, and the Q goes on the bottom, the denominator, which is going to be the coefficient in front. So once you figure out those, it's now time to get our listings of possibilities. So how do we get this 1? Well, a positive 1 divided by this positive 1 gives us 1. And then a negative 1 times a positive 1 gives this 1. So you have to do all the possibilities for each one. So how do we get 2? 2 divided by 1 gives us 2. Negative 2 divided by 1 gives us this 2. Then we got to do 4 divided by 1. Then 4 divided by negative 1 to get 4 and 4. Then we got to come back and do it all over again with the 1 over the 3. So 1 divided by 3, 1/3. Negative 1 over 3 is going to be 1/3, negative 1/3 here. Then we have to do 2 over 3, then 2 over 3 here, and then 4 over 3 here. So how many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 different possibilities. So once we find the factors for P and Q, we divide them. Make sure you're doing each one. So once again, you don't have to kind of necessarily worry about the positive and negative. So if you do 1, just make sure you do plus or minus. If you do 2 divided by 1, do 2, get plus or minus. 4 divided by 1, plus or minus. 1/3, 1 over 3, do plus or minus. So just divide them and then always give yourself another do a plus or minus for each possibility. Now looking at these listings here, we need to figure out which one of these numbers will actually be a solution to this equation up here. So we have 12 to choose from, but again, we don't want to just kind of pick and choose. We kind of want to use our calculator to help us figure out what numbers we know is actually going to be a zero. So if we put this equation into the calculator for y1, we can kind of look at the calculator to help us to figure out what possibilities we can eliminate. So looking at this one, I can eliminate this 2, because if this goes up -1, -2, -3, -4, and then 1, 2, 3, 4, 5, 6, 7, 8, then I know this here does not go. If this is 2 and this one here is 2, this graph does not go through the 2's. So I can get rid of both of these 2's here. Looking at here, can we check 4's? Let's check the 4's. So this is -4, and 1, 2, 3, and this one right here is +4. Notice that the graph does not go through those, so we can get rid of those. Now the rest of them was a little bit difficult, but I think we can probably do 4 over 3, because 4 over 3 is going to be 1 point something something. It looks like it goes through 1 here, and this one here is 1, so this term over here would be the positive part. So we can get rid of the 4 over 3 and the -4 over 3. The rest of them here would be a little bit difficult because we don't know if it actually goes through this 1 or this is a fraction, so it kind of gets real close. So we kind of keep those as possibilities. But what we did was, instead of having 12, we now cut it down to 1, 2, 3, 4, 5, 6 of them, which makes it a lot easier to choose from when we do our guessing and checking. And once again, you can actually try, before you do your synthetic division, you can take the -1, plug it in for the x's here, and remember what number we're supposed to get once we plug that -1 in. We're supposed to look for a remainder of 0. Once we know that's a factor, we can go ahead with the process and go ahead with this one. Remember our steps: drop this down, multiply -1 times 3, put it here, add them together, and continue with the process. We get 0, so we know -1 is a possibility. So because -1 is a possibility, remember we've put it back as a factor, x plus 1. So we kind of change the signs a little bit. If this was a 4, we drop this down to a 3, and we do 3, -14, 14, and -4. And then we figure out what the next 0 is going to be for this part over here, because we already got -1 as one of our zeros. Remember, we're looking for how many answers? It should be 4 of them. So you can do a guess and check again, or you can plug in these fractions, plug in 1/3. If you plug in 1/3 before doing the synthetic division, you notice that you will not get a remainder of 0. So we can kind of eliminate 1/3 as doing synthetic division. It won't work. Or you could just go ahead and do the math and do synthetic division for this one. 1/3 is not a possibility, so we can cross that one out. So let's try 2/3. We try 2/3. We do get a 0, so that's going to be another possibility. So we have -1. And then we have 2/3 to be the answer. So x plus 1, then x minus 2/3, and then we drop it down here once we do our synthetic division. The next thing we want to do is look at this one and try to find the GCF. Find the GCF. We take it out of what number, actually GCF meaning what number can go into this 3, this 12, and 6. It has to go through all 3 of these. What number can you think of goes into all 3? Will be a 3. So if I take out a 3 for this one, leaves me x squared. Divide 3 for this -12 leaves you with 4. And then divide 3 by this 6 and leaves you with 2. For this one here, we try to factor x squared minus 4x plus 2. Once you kind of look at it, we know this won't be able to be a clean factoring, so you won't be able to factor. So what we do is we go to our quadratic formula and to find out the other 2 missing factors. So once we plug in our a, b, and c, we do our math, we should get 2 plus or minus the square root of 2 for this one. So therefore, we have x plus 1. That's the first one we found. And then the 2/3. So we just put the 3 back in front here. So we have 3x minus 2 for this one. And then we have 2 minus the square root of 2, and then 2 plus the square root of 2, because we have to do the plus or minus here with x minus. So we have our 4 answers: 1, 2, 3, 4. So here's another one that you can do for practice. Remember, once you get your total possibilities, there's going to be a long listing of them. Sometimes it could be 12, 16, and maybe 20 possibilities. We don't want to just kind of mess around, take all day to use each one of those possibilities to figure out which one is going to give us a zero. Use a calculator to help to make the process a little quicker. So for this one here, remember, for the P, we're looking at the last one. So remember, what are the possibilities of getting 15? 1 times 15, 3 times 5. Those are my factors. So once I find my 4 factors, put a plus or minus in front of each one of them. The Q goes on the bottom for the denominator. What are the factors of getting 2? The only way to get 2 is 1 times 2. Then you put plus or minus in front of each one of these. Then once again, we do 1 times 1, 1 divided by 1, 3 divided by 1, 5 divided by 2, 15 divided by 2. Write our answers in. Then we got to do 3 over 1, 3 over 2, write our answers in, 5 over 1, and so forth. And then once you do each one, remember each one gets a plus and a minus every time you do it. So now we have our listings of 16 of them. And now we have to figure out which ones are actually going to work. So again, you can plug this in your calculator to kind of help us figure out, do some elimination parts. Once you figure out which one it could be, you can actually figure out by putting in 1 for each x. And remember, if it equals out to 0, that you can put a little check mark above it, because that could be a possibility. That would be a answer for a 0. For this one here, we chose 1/2. You plug 1/2 into each x. If you're doing this, make sure you put your 1/2 in parentheses. When you raise it to the fifth, make sure this 1/2 is in parentheses. You should get an answer to be 0 once you plug it into this equation. So we go ahead and do synthetic division. And for this one here, because we don't have here, so this 2 is going to be the x to the 4th. I don't have an x to the 3rd, so I can skip that one. -4 will be the x squared. I don't have an x, so I can skip that one, and then minus 30. So once again, we're going to find the GCF. What number can go into 2, -4, and 30? That'll be 2. 2 goes into here, 2 goes into here to here, so we take those out. And then we figure out what's going to be the next factors for this next part here. So for here, we can quickly do our factoring out. If we do, we have this part here. We know that for 15, we have 5 and 3. And then for this x to the 4th, we have x squared for both of these. And then the -5 plus the -3 gives us the middle term here. So now we have our factors. We can go ahead and continue on, because remember, we're looking for 5 answers. So we can go ahead and work out our setting each one of these equal to 0. So set this one equal to 0, set this one equal to 0, and this one equal to 0. Set all those equal to 0, we get 1/2 plus or minus the square root of 5 plus or minus the square root of 3i. So this can be written one or two ways. This 2 that you remember you have taken out, you can actually distribute it back in to make it 2x minus 1, or you can leave it on the outside here. It does not matter. Both are considered to be correct. So this is going to be the way you can write it for the first one, or you can write it this way here. So these are going to be my factors for this particular problem. So now we're going to talk about Descartes' rule of sign. So this is basically what we're going to do is this helps us figure out the way the answer should look like. If we're going to have how many positives, how many negatives, how many imaginary. So looking at an example for this one here, we have one positive here, and then another, so 2 positives. Anytime you have an I, that's considered to be an imaginary. So here we have two positives, 1 negative, and 2 imaginaries. So Descartes you can actually do this step first and kind of figure out what the layout is going to be. How many positives you have, how many negative answers you have, how many imaginary answers you will have for it. Because remember, because of this degree here, we have 5 answers, but the Descartes kind of let us know beforehand how many each one of these categories will we have as a 0. So how do we start this process? The first thing we need to do is look at the equation, the function, and determine how many times do you see a sign change. So here's a positive, so it changes sign to a negative, so that's 1 time. It did not change this way, so we keep it still at 1, but it did get changed here. So how many times did it change signs? From here to here, 1, and then from here to here, 2 times. There's my sign change from here to here. So we have 2 sign changes. Now for negative, we're going to actually take the negative sign and plug it in for it. If you plug in a negative for a negative x for a odd exponent, you should get a negative response. So that means we just change the sign. If you put in a negative x for a square, that actually gives us a positive. So nothing changes here because a positive and negative makes a negative. So another way to look at it is if you just want to go in and just flip all the signs. So this is a positive, this is a minus, this is a minus. You keep it as a minus for here. So flip all the signs, meaning if it has an odd, you flip the sign. If it has an even, you keep it the same. So odd exponents, change the sign. Even exponents, keep it the same. Same thing for here. Here is an odd exponent, change the sign. Because this is considered to be a 0, x is 0, you keep it the same for this one. So we do the negative. Then we do the same thing. How many times do you see the sign change? Well, from here to here it did not change, but I see that it changed from a negative to a positive here. That's one time it changed. And then positive, positive, it never changed signs again. So this one here should be 1. So the positive part comes from your positive, your original function. Then once we put the negative in, change the sign if it's an odd, keep it the same if it's an even. Figure out the number of times you see it flip signs. Now remember, to get the imaginary, if we have a total of 5 and I have 2 here and 1 here, which makes 3, how many is left over? Which should be 2. 2 plus 2 is 4, plus 1 is the 5. For your next row, you need to determine if you can subtract whatever we're discussing, the positive or what we just started with. Can you subtract that by 2? If you can, which we can because it does give us a 0, not a negative number. If you get a 0 or a 1, then that means you continue to subtract by 2 each time. So if this one is a 0, this one here remains the 1. You keep this the same. If I have 0 here and 1 here, so how many total should I have? This one should be 4. So here it gives us a possibility that we should have 2 positives, 1 negative, and 2 real solutions, or there's a possibility we can have no positives, 1 negative, and 4 imaginary for this particular polynomial once we do the answers, get to our answer. So here's another one. So here's our positive. We figure out how many sign changes we have. And then we do our negative. Remember the positives, if it's a even, it stays the same. If it's an odd, you flip it, the sign. So here, how many times do you see the sign change? 1, 2, 3, 4. It actually changed sign for every part of this. So it changed signs 4 times. So this is my 4. Looking at the second one for the negatives, how many times you see a sign change here? Well, all of it's positive, so it actually never changed signs. That's why we put 0 here. So if my possible answers is 4, because of the first leading term, then this one gets a 0, this one gets a 0. Now, can I subtract this by 2? If your answer is yes, go ahead and do that and put 2 here. So this time, if this is 2, remember this remains 0 for each one of these parts. The imaginary possibility can be 2 also. That makes 2 plus 2 gives us 4. Now again, can you ask yourself, can you subtract by 2 again? The answer is yes, we can. So we have 0, 0 here. We have a total of 4 imaginaries here. I did not write another row because can you subtract this by 0 again? No, you can't. So that's when you stop. Remember, if this is a 0 or a 1, you cannot subtract by 2 each time to get a new row. So for this possible one, we have 4 possibles in a total here. So that's how you do Descartes' rule for polynomials to figure out what the answer should look like at the end. If you have any questions, concerns, please let me know.